Hey, geometry students. This week we are learning about the Pythagorean Theorem. And so for a lot of you, you've seen this before. You remember it maybe from 7th or 8th grade or maybe algebra. For others of you, it's, a distant memory, if anything. So we're going to definitely refresh those memories and learn about Pythagorean Theorem today. So the main thing that most people remember, like if you ask your parents what's the Pythagorean theorem, they might remember something about a squared plus b squared equals c squared. So that's definitely an important part. But where do these a, b's, and c's come from? What does this have to do with? Pythagorean theorem is only for right triangles. So if you remember back to our unit on triangles, we classified them. Right triangles have one right angle. We didn't talk much else about specifics on the sides or anything like that, though, for right triangles. So this a squared plus b squared equals c squared Pythagorean theorem, that has to do with the sides of a right triangle. So if you were to label the sides of a right triangle, well, first there are some vocab words that go with these. If you remember the hypotenuse leg theorem that we talked about, you'll remember that the hypotenuse is the longest side of the right triangle, and it's across from the right angle. So that one is the hypotenuse. And then the other two sides were called legs. So the hypotenuse leg theorem told us that if the hypotenuse and one of the legs of two right triangles are the same, then the two triangles are congruent to each other. So we're just going to kind of continue in our knowledge of right triangles. The hypotenuse in this Pythagorean theorem, the length of the hypotenuse is the letter c. The other two, the legs, are A and B. So we have the sides A, B, and C. It doesn't matter which of the legs is A and which of the legs is B. Some people like the short leg to be A and the long leg to be B. Doesn't really matter. The one that really does matter is C. The hypotenuse, the longest side, has to be C. So let's go ahead and try some examples that have to do with this Pythagorean theorem. So the first thing is, one way that you'll notice the Pythagorean theorem used a lot is if you're given a right triangle and you're given two of the sides, but you don't know the length of the third side. So sometimes you might be given both of the legs. Sometimes they might go, okay, this is 3, this is 4. What's the missing side? So the first thing you would want to do is go through and label your sides A, B, and C. So we want to make sure that we know that the hypotenuse, this side right here, is C. And then these two are A and B. And with these two, it does not matter the order, which one's A, which one's B. All right, and then we're just going to plug these things into this Pythagorean theorem. So A squared would be 3 squared. B squared would be 4 squared. And then equals C squared. And I don't know what C is, so I'm just going to use the letter C. You could use X if you would like to. If you like solving for X better, that's fine. Then 3 squared is 9. 4 squared is 16. Equals C squared. So we just want to simplify those. And then once I've squared them, I can add them together. So 25 equals C squared. And then we'll take the square root of both sides to get rid of the square, because we're not done just when we have C squared. We want regular C. So the square root cancels out the square, and we are left with C is 5. So that missing side is 5 units long. This might kind of remind you of the distance formula, because the distance formula and Pythagorean theorem are very closely related. So yeah, anyway, let's go ahead and do another one, except this time we're not going to have the hypotenuse. We're going to solve for the hypotenuse. Okay. So for this one, we have a right triangle. This side is 13 units long. This side is 5 units long. And we're missing that side right there. Okay, so the first thing we want to do is make sure that we identify the hypotenuse. The hypotenuse is across from the right angle. So 13 would be the letter C, our hypotenuse. And then with these two, it doesn't matter which one's A, which one's B. I'm going to say that's A, that's B. And then we're going to plug things into the Pythagorean theorem, just like we did on the last one. So we have A squared, so 5 squared, plus B squared. I don't know what B is, so I'm just going to leave it as B squared. You could put X if you would like. And then equals C squared, so 13 squared. Then we want to square 5 and square 13. 5 times 5 is 25. 13 times 13 is 169. Then once we get here, we need to solve for B. So to do that, I need to subtract 25 from both sides. And so we're left over here with just B squared equals 144. But we're not quite done yet. This side length is not 144. We have to square root both sides to get rid of the square to get B equals 12. So our missing side for that one is 12. Okay, so those are two examples, one where you're given the hypotenuse and you have to find one of the legs. The other one where you're given the legs and you have to find the hypotenuse. It's all plugging things into this A squared plus B squared equals C squared. Okay, so let's do a different type of problem that still has to do with the Pythagorean theorem. Actually, it has to do with the converse of the Pythagorean theorem. So the Pythagorean theorem says that if your triangle is a right triangle, then this happens with the sides, where C is the hypotenuse. The converse says that if this works out, if A squared plus B squared does equal C squared, then the triangle is a right triangle. So this is a way that we can tell whether a triangle is a right triangle or not. So let's go ahead and take a look at, let's say our triangle has sides that are, 7, 8, and 12. We're going to see if 7, 8, and 12 will make a right triangle. So what we have to do in this situation is we have to plug these numbers in as A, B, and C. But we also need to be careful and make sure, in case we aren't given the numbers in order of least to greatest, we want to make sure that we're using the biggest side as C, since the hypotenuse is always the biggest side, along with being across from the right angle. So we want to make sure we label that the biggest side is C, and then these two would be A and B. So in this case, the numbers were given in order, which makes our lives easier. Okay, so we're going to go 7 squared plus 8 squared equals 12 squared, and we're going to see if this works out, if those are actually equal. So 7 squared is 49, 8 squared is 64, 12 squared is 144. All right, so then adding these two together, we get 113. Is 113 equal to 144? No, it's not. So since this is not equal, then we would say, no, this is not a right triangle. So that's what that tells me. If the Pythagorean theorem does not work out, it's not a right triangle. Okay, so let's try another one of these real quick. What if my sides were, 24, 7, and 25? Would that make a right triangle? Let's find out. So first of all, we're plugging this into the Pythagorean theorem, so we need to make sure that we match the biggest side with the letter C. So the biggest side of all these three is 25, so 25 is going to be C. And then it doesn't matter what these two are. Those will be A and B. And then we're going to plug them into A squared plus B squared equals C squared. So 24 squared plus 7 squared equals 25 squared. 24 squared is 576. 7 squared is 49. And then 25 squared is 625. Okay. So then we add these two together. 576 plus 49 does equal 625. So this one, it does work. We get a true statement. So that tells me that yes, the side lengths 24, 7, and 25 do make a right triangle. Okay. So that's all I've got for you guys for today. If you have questions, send me an email, leave a comment, or come to office hours. Have a great day.